No more boring problems. This beam deflection problem has a dragon. So we've got a W10 by 15 A36 structural steel beam, 40 feet long. It's going to be used to build the world's largest cat tower. Your TA Indiana is already peacefully napping, but there's a dragon in the sky and it's going to swoop in and catch him unless your TA Serenity can save the day. So we need to calculate how many pounds of snacks does TA Serenity need to eat so that when she jumps out onto the beam, that the whole beam sags and Indiana's deflection goes down by a total of 1 inch, which means that when the dragon swoops in, it's just barely going to miss him and Indiana will be okay. Because as we all know, dragons are just like students. They get frustrated and give up after one failed attempt. Not you though, you're awesome. I'm talking about other students. All right, first mistake that I would see students make for this type of problem is to go to the cantilever beam section in the back, right? If you find yourself on this page, flip to the next page. You need to look for a simply supported beam, right, with 2 supports on either side. So for this problem, our force is not going to be right in the middle. Serenity is only going to jump 15 feet in. So we need to grab this second line, which has a force that is slightly off center. Next mistake would be to grab the deflection equation because this is a deflection problem, right? But no, the deflection equation here is to try to find the deflection exactly where the force is. We actually want to know the deflection somewhere else. This means we need the elastic curve. The elastic curve is how you find the deflection everywhere on the beam, where you can plug in any location for X that you want. But there's one big catch, which is actually a big problem for us. This only works for X less than A. This means we need to be on the left side of the force. But if Serenity's jumping from the left, Indiana is on the right side of her, not the left. So this means we're going to have to actually flip and reverse our problem. We need to pretend we're on the back side, looking at the beam from the other side, so that Indiana will be on the left and Serenity will be on the right. That way our position X will be less than A. Your TA Serenity here is just, she cannot find a comfortable spot. You need to go eat more snacks. Right? So just like this, we rearrange the problem. So we got TA Indiana on the left, TA Serenity on the right. And you thought you were going to learn how to solve beam deflection problems. You didn't realize this was going to be a tutorial about how to draw a dragon. But yeah, it's, we're all about providing extra value here, right? So you just start off by drawing an S and then kind of a different sort of S. Some little angry eyebrows here. And the last step that really sails it are the consummate V's that look like scales. And if you want to see, if you do a YouTube search for Trogdor the Burninator, that's how I learned to draw a dragon. All right, writing out all of our constants, it looks like this is going to be mostly a plug and chug problem, but we're going to have to do some unit conversions first. Since I have deflection in inches, let me go ahead and convert all of my feet to inches because that's also what E and I are probably going to be in terms per inch anyway. All right, your TA Serenity's got to get back. All right, your TA Serenity has to go back to eating snacks to finish. She's doing her part. We got to finish our part of the problem. So I'm going to the FE reference manual table, look up A structural steel. It says 29 KSI, but then you see at the top, that's times 10 to the third, so it's actually 29,000 kips per inches squared. Which, of course, now it's a good thing that we actually went to inches instead of feet before. Now we'll go up and look for I. This is a W10 by 15 beam. So I'll just go find my table. Since this is a downward force, bending is going to happen across the horizontal axis, which is the x-axis. I'm going to the IX column. So now we've got an inches to the fourth as the area moment of inertia for this wide flange beam. All right, start plugging in numbers. I'm going to start crossing out units just to make sure that all of the inches cancel out. So this is going to give us P in kip because that is the unit for our E, Young's modulus, in terms of KSI, so P will be in kip. And at first when I was writing this down, my value V should be -1 inch if I want Indy to be deflected downwards, so I do need to put that in as a -1. So plug in all the numbers, do some calculator work. 1.451 kip, about 1,400 pounds. So if one bag of snacks is 3 ounces, then if TA Serenity can scarf down 7,700 bags of snacks in time before the dragon arrives, then your TA Indiana will be perfectly safe. And your TA Serenity is a machine, so I have no doubt that she'll be able to accomplish this. I hope you had fun with this video. I hope you learned something, and good luck on your next test.